And to find the potential function for this example above, that's this one, right? I mean, since we know it's conservative, then it does have a potential function, so how would we go about doing that? Well, we could start by saying, let's integrate this with respect to x. And of course, if we integrated this with respect to x, it's a little tricky, but if you let u equal x squared plus y squared, and the derivative of u is right here, it's really du over u squared, and the derivative of du over u squared is u to the negative 1. Well, this is our u to the, negative u to the negative 1. I forgot about the fact that it was negative 2. So negative u to the negative 1, and there it is, negative u to the negative 1 if our u is this. And then plus some constant. But now here's a little tricky part. It's a constant, yes, but it's a constant regarding x. So that means it's some constant function regarding x, and that means it's a constant function of y. So it's plus some cy. And now if we integrate the same thing, integrate this dy, the integration turns out to be the same, but then that would be plus some constant function of x. See? Because, you know, the derivative of this one, the integral of this one will give us this function, the integral of this would give us this function, plus some constant function of x, this one plus some constant function of y. But those two things have to be equal to each other. And so, like, if this constant function of y had an x in it, well, it can't. Just the same as this one can't have a function, constant function of x can't have a y in it. So therefore, the only constant would be an arbitrary number constant, like c. So here's our potential function, f of x, y equals negative 1 over x squared plus y squared plus c. So the potential function for this vector field, remember, you know, y that is this, 2x over this denominator, right, is the derivative of something, and 2y over this denominator is the derivative of something. What's the derivative of? Well, you can see what's the derivative of if you integrate it. So we integrate it, right? Integrate both of these. This one will be plus some constant function of y, this one will be plus some constant function of x. Sometimes that won't be real obvious the way they work out, but this one's not too bad. So we wind up with constant of integration just being a number, and this is our function.